Welcome to DC to Daylight. I'm Aaron, amateur radio call sign N6ACA. Today we'll be talking about playing ham radio from 40,000 feet. Recently I was on a trip to Oregon to visit with family and take care of some important tasks. Normally I try to participate in ham radio on a daily basis, but as you know, there are higher priorities. I was able to find a lull in my schedule in the last day in town to activate a local POTA entity with 15 contacts in 45 minutes. During my time there, solar conditions were awful. This may not seem like a lot, but it's more than 10 and got Oregon on the map for me. On my flight from Portland, Oregon, back to Oakland, California, I was flying Southwest Airlines. I am fairly frugal and never pay for Wi-Fi on the flights I take. Currently, there is a promotion on Southwest in their partnership with T-Mobile that gives free Wi-Fi to Southwest Rapid Rewards members. I decided to use it and have some fun ham radio play. The first order of business was to do APRS from the air using the internet connectivity. The second item was to remote into my home station in California and play some FT8 digital modes. Well, I've been a user of APRS.FI for the last 20 or so years. I finally sprung for the iPhone application, which allows you to have direct IP access into their network to access APRS. So I've got the app up here. I have it on my iPhone there. And traditionally, when you don't have a full internet connection, if you have a messaging only connection on airplane, you don't actually get GPS information. So with the Southwest IP connectivity, that with full access, even in airplane mode, I'm getting GPS access. So what we're showing here is the airplane that we're on, updating GPS information and sending information to the APRS IS, so into the main APRS feed that feeds, will at least input into APRS.FI and other APRS services. So we see it just continues to update the location information and is beaconing over the network. And we can see here that I've got it in airplane mode connected to the Southwest Wi-Fi, and it is enabled. So now we're going to actually look at doing FT8. So I've got a tailscale connection between my phone and a home machine, and over that connection I'm using VNC to connect up to a Windows 10 laptop. So we see here that I've got MSHV up and running. I've been monitoring FT8 remotely, and we can see a November 4 Echo X-Ray Alpha. Try to make a connection with them. They're not calling CQ, but they're active and they're strong. So see, so the latency is pretty high on this connection. So I've got the connection overhead of the Wi-Fi, going through the satellite, as well as the layer of encryption through tailscale. And frankly, it's not that bad, but in some cases the user interface is fairly slow. So as we wait and wait and wait, this is not the experience you get through, other applications through, let's say, Flex Radio, where they have everything in. This is layers of free software, so you're getting what you pay for. So here we've changed to 40 meters. I use FLRig to connect it. This is a Shigu G90. I've got it into a off-center fed dipole. It's a 40 to 6 meter dipole on the roof of my QTH. It doesn't tune exactly 1-to-1, so we'll just tighten it up by tuning it. And as you can see, this is not very efficient. Connecting into a Windows machine from an iPhone, but it does work. So right there, I'm clearing the connection, or the output window there, so I can see currently what's coming in, and so we'll see what it decodes. And so we see W6 TOX in the middle of a QSO. So let's call them directly and see what if they hear me. So this is completely unreadable, zoomed far out, but you can sort of see the way the screen is set up. So I'm calling them right now. They're in the middle of a QSO with someone else. It really doesn't matter if you're direct calling, if you're on a different frequency, if you're not overlapping and where you're transmitting is free. It's just like operating split on SSB or on CW. You know, multiple callers at the same time, just as long as you're not overlapping on the same frequency that you have, another caller coming in. Can't always tell because, as you know, the frequency space is finite and the world has a lot of hams. So this radio I've got running is the finals on it are pretty shot, so it has a decent antenna, but it's got about 1 watt of output power on it. The other thing I would recommend if you're running a setup like this is put a cheap power control unit. I've got a Wi-Fi connected power control on this box, so in the case of an issue, we can basically shut down the radio remotely. If you're wide open and you can't cut the PTT remotely, then you can just shut off the radio to have full control, which you should be able to have that type of control of a system if you're controlling it remotely, or have someone that can have hands on that radio where they can kill the power. Alright, so we're not having success here so far. We've got a decent sized signal coming in. So yeah, +3. I think they're also in the San Francisco Bay Area where I live. I'll have to look up their call sign. All right, so we see Whiskey 6. What is the call sign there? It's under the mouse there. And as a lot of people comment, sometimes playing FT8 is like watching paint dry. And, frankly, if you have nothing else going on a plane or somewhere, that's a viable option for entertainment, is to actually get the connectivity running and be able to do this remotely. Because over this amount of bandwidth with the equipment that I have that I'm showing you right now, it would be not possible to do a CW with the amount of latency, and beyond the fact that I can't operate CW, as well as the single sideband would be impossible to do as well, just due to the latency and the bandwidth. So as you can see here, it's a Whiskey 6 RHB here. So we've got a signal report back from them. I've sent a response, basically giving the signal report on there. Hooray, hooray, hooray. And so let's see if we can finish that QSO. Yes, we have. So basically, we're able to complete that QSO, and that's incredibly exciting. So as some would say, that's watching paint dry. Others would say I've made a connection. This is not DX, but it's just sort of a proof of concept outside of, from an airplane at 40,000 feet that I've made connections through a satellite back to my home, and then initiated a FT8 QSO and completed it. And we can see the beautiful airplane view here. The whole time I've been recording this, that's what I've got out of my face. So back to APRS. So we've still been tracking. In the background, we've been running the app, even as we've been using VNC to make a connection. So what we do get is we do get mapping information. The one thing that we don't get is accurate mapping information. So with the connectivity that we have over the airplane, I'm able to send tracking data, altitude information, latitude and longitude information. What doesn't happen is the updated map information. So like once I'm outside of the Portland area, the map itself stopped updating. I'm not sure exactly why that was the case. But as you can see through the information on latitude and longitude and altitude, that actually keeps updating. So we just keep going here. This is an 1.5-hour flight. We can see the raw packets that the application is sending to the APRS IS server. Just all TCP packets that have the information that's shown on the screen. One thing, yeah, we just have the continuous view. It's a beautiful time as we're flying over northern California at this point. We can see the beautiful clouds. And so as we continue to play with the APRS.FI app, so we just continue to beacon. It's beacons on about a 15-second interval, unless it goes faster, or if we go through, you can actually beacon by hand if you're in a fixed location, but you want to update the timeliness of the location. So if you were physically in a area where I'm not going as fast as I am right now, I could basically update so that people would know that I'm currently in a specific area. And so as we descended into the San Francisco Bay Area, and specifically to Oakland, our Starlink connection or T-Mobile connection, or however we're connecting into the satellite area that gives us the internet connectivity, it was still connected, but it doesn't seem as if our GPS locations were logged appropriately. But we did have a great view. So even as the phone still showed connectivity into the APRS network, we didn't seem to have real connectivity. It wasn't recorded, so I'm not sure what the issue was with that. But we had the great view of the San Francisco skyline. We were able to see the waterfront area as well as Sutro Tower far off in the distance. Which, being able to see it directly from miles away shows how large it is. So thank you for joining me and playing around with my radio and making QSOs. As an epilogue to our story today, we can see that the information for APRS, it actually recorded all of the altitude and location information along the whole path, even if it didn't update in the application. So we can see that the position spots within the APRS network were shown. So I'm using aprs.to as the website displaying the data. We can see that all the way down from Oregon to California that spots were received, and then it right around north of San Francisco, that's when we lost our data. So I assume that's when we lost our internet link over the satellite. Well, thanks for joining us on this trip 73, and hope to see you next time.